The problem involves a dataset with two features, x1 and x2, representing characteristics of data points, and three classes, A, B, and C, representing categories to which these data points belong. Each data point in the dataset is described by two features, x1 and x2. Think of these as two measurements or attributes for each data point. For example, x1 could be height and x2 could be weight. The NearestCentroid classifier first calculates the centroid for each class. A centroid is simply the average, mean, location of all the data points belonging to that class. It's like finding the center of mass for each group of points. The centroid for class A is calculated as 2, 3. This means the average x1 value for all points in class A is 2, and the average x2 value is 3. Similarly, the average x1 and x2 values for all points in class B are 7 and 5, respectively. This is class B's centroid. The centroid for class C is 4, 1. This represents the average location of all points belonging to class C in the feature space. A new data point arrives with features 5, 4. The goal is to predict which class, A, B, or C, this new point belongs to, using the centroids calculated earlier. To make a prediction, we use the Euclidean distance formula to determine how far the new data point is from each class's centroid. The Euclidean distance between 2 points, x1, y1, and x2, y2, is square root x2 x1 squared plus y2 y1 squared. The NearestCentroid classifier assigns the new data point to the class whose centroid is closest, has the smallest Euclidean distance. This is the core idea of the classifier. Proximity to class centroids is used for prediction. Based on the calculated distances to each centroid, the prediction is class B. The algorithm chose class B because its centroid is closest to the new data point, 5, 4. This section introduces the multiple-choice quiz questions based on the preceding analysis of the NearestCentroid classifier and the example dataset. It sets the stage for evaluating understanding of the concepts covered. This section introduces the multiple-choice quiz questions based on the preceding analysis of the NearestCentroid classifier and the example dataset. It sets the stage for evaluating understanding of the concepts covered. This is the core question of the quiz. It asks you to assess the validity of several statements based on the prediction made by the NearestCentroid algorithm for the new data point, 5, 4. Think carefully about the algorithm's process and how the distance calculations influence the final classification. This is the core question of the quiz. It asks you to assess the validity of several statements based on the prediction made by the NearestCentroid algorithm for the new data point, 5, 4. Think carefully about the algorithm's process and how the distance calculations influence the final classification. This statement proposes that the algorithm will classify the new data point as belonging to class B. Consider the calculated distances to each centroid to determine if this is true. This statement proposes that the algorithm will classify the new data point as belonging to class B. Consider the calculated distances to each centroid to determine if this is true. This statement compares the Euclidean distances between the new data point and the centroids of classes A and C. Refer back to the calculated distances and check if the inequality holds. This statement compares the Euclidean distances between the new data point and the centroids of classes A and C. Refer back to the calculated distances and check if the inequality holds. This statement evaluates the suitability of the Manhattan distance as a metric for the NearestCentroid classifier. Remember, NearestCentroid uses Euclidean distance by default. Is there flexibility to change this? Does the problem state any such change? This statement evaluates the suitability of the Manhattan distance as a metric for the NearestCentroid classifier. Remember, NearestCentroid uses Euclidean distance by default. Is there flexibility to change this? Does the problem state any such change? This statement checks if the NearestCentroid classifier correctly assigns the new data point, 5, 4, to class B. We'll need to calculate the distances from the new point to each class centroid and see which is the smallest. This is about verifying the accuracy of the classifier's prediction. This statement asks us to compare the Euclidean distances, the straight line distances, between the new data point, 5, 4, and the centroids of class A, 2, 3, and class C, 4, 1. We need to compute those distances and see which one is larger. This helps us understand the relative proximity of the new data point to different classes. This statement tests your knowledge of the NearestCentroid classifier's default distance metric. The NearestCentroid classifier uses Euclidean distance by default, not Manhattan distance. Manhattan distance, also known as the L1 distance, calculates the sum of absolute differences between coordinates. Euclidean distance is the straight line distance. This tests your understanding of the classifier's inner workings and distance metric choices. This statement explores the fundamental principle behind NearestCentroid's operation. It asks whether the classification is determined solely by the mean values, centroids, of the features for each class. The NearestCentroid classifier works by identifying the closest centroid to the new data point. This verifies whether that core concept is understood. The problem involves using scikit-learn's NearestCentroid classifier, a machine learning algorithm that classifies data points based on their proximity to the centroids, means, of different classes. We'll be exploring how it works and interpreting its predictions. The dataset contains two features, x1 and x2, and three classes, A, B, and C. This means each data point is represented by two values, and belongs to one of three categories. Each data point has two features, x1 and x2, which are used by the NearestCentroid algorithm to determine the class. There are three possible classes, A, B, and C. The centroids represent the average values of x1 and x2 for each class. NearestCentroid first computes these averages from the training data. For class A, the centroid is 2, 3, for class B it's 7, 5, and for class C it's 4, 1. These are the reference points for classification. This is the data point we want to classify using the NearestCentroid algorithm. Its x1 value is 5 and its x2 value is 4. We need to determine which class centroid this point is closest to. The Euclidean distance is calculated to measure the straight line distance between the new data point and each class centroid. The formula is the square root of the sum of the squared differences between the corresponding coordinates. For example, the distance to class A is calculated as sqrt, 5 to 2, squared plus 4 to 3, squared. These are the calculated Euclidean distances. The distance to class A is approximately 3.16, and the distance to class B is approximately 2.24. This calculation helps determine which class is nearest to the new data point. Because the distance to class B's centroid, approximately 2.24, is the shortest among all three classes, the NearestCentroid algorithm will predict that the new data point, 5, 4, belongs to class B. The problem involves a dataset with two features, x1 and x2, and three classes, A, B, and C. This forms the basis for the classification task. Using the NearestCentroid classifier, we'll be using this data to understand how the algorithm works. These are the centroids, the average coordinates, for each of the three classes, A, B, and C, in the dataset. The NearestCentroid classifier uses these centroids to make predictions. Notice how each class is represented by a pair of numbers. These are the mean values of the x1 and x2 features for that class, respectively. This is the new data point that we need to classify. It has two features, x1 equals 5 and x2 equals 4. The NearestCentroid classifier will determine which of the three classes this point is closest to. This is the prediction made by the NearestCentroid classifier. After calculating the distances between the new data point and the centroids of each class, it concludes that the new data point is closest to the centroid of class B.